Alright folks, so in this video I want to show you how we can calculate probabilities of the normal distribution using our calculator. Okay, so from the previous video we know all about the normal distribution. We know it's symmetric, we know that it's centered at the mean, and we know that the standard deviation tells us how wide the distribution is. So here they're just showing us a normal curve with the mean of mu and a standard deviation of sigma. All right, when the population mean and standard deviation are known, a probability can be calculated using a calculator. So we're going to use what's called the Normal Cdf function in our calculator. So the way that you get to that is that you hit your second vars button. In fact, I'll show you what that looks like right now. Where are you at? I'll clear that out. So how do we get to our Normal Cdf? We hit second, and then we hit the vars button. And then number 2, Normal Cdf is what we're going to use here. I'll click on it and you'll see 4 different values that we need to input into the calculator. We need to give it the lower bound, the upper bound, the mean, and the standard deviation. And so I'll go into a little more detail in just a little while about what I mean about the lower bound, the upper bound, the mean, and the standard deviation. And so here they're just once again showing us the steps that we just completed. An important part is that in case your calculator is not updated, whenever you click on Normal CDF, you may see it may take you back to the home screen. Well, if that's the case, then what you need to do is you need to put in your lower bound, upper bound, your mean, and your standard deviation, comma separated. And it has to be in that order: lower, upper, mean, standard deviation. Okay. Um, and so actually, we'll come back to that question in a second. Actually, before I do that, I do want to go over how do you diagnose, or how do you come up with your upper and lower bounds when it comes to these normal distributions, okay? So really all when it comes to normal distributions, there's going to be 3 cases as far as how do we find probabilities. 3 cases. The first case will be this. Okay, I'm going to draw you a picture. Let's suppose we have our normal distribution, okay? And let's say this is the standard normal. So if you remember we said the standard normal, the z-distribution, was one where the mean is 0 and the standard deviation is 1. So what if you're asked to find, let's do this. Let's say you were asked to find the probability that you get a z-score that's less than that specified z1. And so the key here is that we're trying to find the probability that a z-score is less than z1. So what that means is that all of this shaded region here, we're trying to figure out what's the probability that z is less than z1. Well, for a standard normal distribution, if just for any normal distribution, a probability is the same thing as finding an area. So areas under the normal curve and to the left or to the right of a z-score is how we find probabilities. In this case, our probability is the area that's under the curve but to the left of z1. So it's the area under the curve but to the left of z1. All right, so the lower bound for this scenario will be a negative infinity. And why is that? So whenever we talk about your lower bound and your upper bound, we're talking about, well, lower bound means the smallest z-score in your shaded region, or the smallest x value once we get to distributions that are not standard normal. And so in this case, our z distribution extends infinitely to the left, right? So these tails here that I'm trying to draw, they get super, super close to the z-axis, but they never cross, excuse me. They never touch. So what that means is that our lower bound, we're going infinitely to the left. And so, well, the lower bound technically would be a negative infinity. However, we cannot write negative infinity in the calculator. So instead, what I like to do is a negative 1 E99 to represent my negative infinity. And what is this? This is, well, scientific notation. All right, E just means 10 to the 99th power, right? So a negative 1 times, well, just a positive 1 times e to the 99 will be a positive 1 times 10 to the 99. That's a huge number. But if we multiply that by negative 1, now it becomes a really, really small number. Okay. So our lower bound is negative 1e99 for this left area case. Your upper bound will be Z1 because in the shaded region, it's very important, in the shaded region, the largest z-score is Z1. Has to be within the shaded region. Okay? Because this is a standard normal distribution, we discussed this in the last video, we know that the mean is 0 and the standard deviation is 1. Okay? So this is one example of finding the distribution, the area to the left of a z-score, excuse me. All right? There's another case. What if instead we're trying to find the area to the right of Z1? See if I can draw that picture. Okay. Let's say we have a picture looks like this. Let's say, I don't know, let's say our Z1 is over here. It could be anywhere along our horizontal axis. Let's say Z1 is there. And let's say now we are trying to find now this shaded area. Okay. So now the question becomes, what is our lowers and uppers, right? So our lower bound is going to be a little different than the previous example because now what's the smallest z-score in that green shaded region? The smallest z-score is going to be Z1. That's why that is our lower bound. We're not getting beyond or to the left of that Z1. Now what's our upper bound? Our upper bound will be the largest z-score in the shaded area. In this case, it's going to be a positive infinity, which we will represent that by a positive 1 E99. And I'll show you how to type this E in the calculator in just a second. And because we're still dealing with the z distribution, the mean is 0 and the standard deviation is 1. Okay. If you have a different type of normal distribution, they will tell you the mean and the standard deviation, just like in the problem we saw just a minute or two ago. All right, the third and final case I want to illustrate before I jump into some examples is what happens if we're trying to find the area or the probability that we're between two z-scores. Okay, let's put a z1 here. Let's put a z2 here. Okay. All right. I'm sorry. Before I do this, let me go back to the previous example I did. The right area problem is the probability notation, as I like to call it, looks like this. It's the probability that z is to the right or greater than z1. So I want you guys to get in the habit of writing your these probability problems. Rewrite the wording as in probability notation. So in this case, we're trying to find the probability that z1 is less than z is less than z2. What we mean here is that what's the probability that we have a z-score that goes in between the z1 and the z2? Okay. Well, in this case, I think this is actually the easiest case to understand what's your lower and your upper. So in that shaded region we have there, what's our lower bound? The lower will be z1. And your upper would be z2. Okay, still the z distribution, so mean is 0, standard deviation is 1. All right. Okay, so it's very important that everybody understands how you determine your lowers and your uppers when it comes to these three different cases. All right, so let's kind of go through a few examples here. Okay, I'm going to stick with the z distribution here. What if, for example, you were asked to find the probability that z is greater than a negative 1.03? Okay. So in this case, we're talking about going to the right of a negative 1.03. So that means that our lower bound will be a negative 1.03. Okay, if you don't quite understand why that's a lower bound, rewind just a few seconds ago and remember the case. As a matter of fact, I'll go back to it. Remember the case where we talked about the area to the right, the greater than, that means that the lower bound was the specified z-score. So here our lower bound is a negative 1.03. Our upper bound will be a positive infinity. For us, it'll be a positive 1 E99. The mean is 0 because it's the z distribution. Standard deviation is 1. And so now we have to find that probability. So how do we do that? We're going to go to our calculator. See if I can load mine up real quick. There it is. Okay. So we said the lower bound was, well, I forgot. The lower bound is negative 1.03. So negative 1.03. Okay. Make sure I got my negative in there. Okay. Our upper bound was 1e99. Okay. So 1. And then your e is the secondary function right above your comma. So I'm going to hit second comma. And there's the scientific notation e. Raise that to the 99th power because I want to have a positive infinity there. So positive 1e to 99. Mean is 0. Standard deviation is 1. I'm going to paste that to the home screen. If your calculator is not updated and you have to put this in comma separated, this is how it should look once you put it in comma separated. Okay, we got normal CDF selected. We got our lower, upper, mean, standard deviation, comma separated. Hit enter. And there we go. To 3 decimal places, we should get a 0.848 as our probability there. So this equals 0.848. Okay. All right, let's try another one. For example, what about the probability? It keeps on doing that. What about the probability that our z-score is less than a positive 0.65? Okay. All right. So now we're talking about going to the left of a 0.65. So that means our lower bound will be negative infinity. Oh, sorry about that. Our lower bound will be negative 1e99. Because we're going infinitely to the left. We're not stopping as we go to the left, but as we continue to the right, that'll tell us our upper bound. We have to stop at a 0.65. Okay. Mean is 0. Standard deviation is 1. That's always the case for the standard normal distribution. And now it's just a matter of putting this in our calculator. Okay. So second vars, normal CDF. The lower bound, let me clear that out. The lower bound was a negative, there's our negative button, 1 e, so second comma, 99. Upper bound was a 0.65. And the mean stays the same, 0. Standard deviation is 1. Paste that to the home screen. Or if you're old school, remember you do the comma separated. Hit enter, and 0.742. So this equals 0.742. Okay. I don't know why it keeps on doing that. All right. The third case is, what about this one? Third example, I should say. What's the probability that we have a 0.25 is less than z is less than a 1.01? Okay. Our lower bound in this case will be a 0.25. The upper will be a 1.01. Y'all know the drill about the mean and the standard deviation. To the calculator we go. Okay, second vars. Okay, the lower was a 0.25. I believe the upper was a 1.01. Mean is 0. Standard deviation is 1. Let's paste and calculate. 0.245 is our answer there. 0.245. All right. So that's how we find probabilities of the standard normal distribution. And so I just want to quickly remind you guys, look, so probabilities must be between 0 and 1. Probabilities are between 0 and 1. And what that means is that you'll never have a negative probability, and you'll never have a probability that's greater than 1. So just keep that in mind. You'll never have a negative probability, and a probability can never be greater than 1. Okay, so here's some practice. So we did some examples of the standard normal distribution. Now we could do the exact same things for normal distributions, but they don't even have to be standard. They could be just any normal distribution. For example here, the random variable x records a randomly selected score on a test where the distribution for the score is normal with a mean of 75 and a standard deviation of 15. Find the probability that x is between 80 and 90. All right, folks, as soon as you see the word find the probability, as soon as you realize that, know that this is a normal CDF type of problem. Okay, so normal CDF type of problem. And so now all we have to do is figure out our lowers, our uppers, and then put in the mean and standard deviation, and we're done. Our lower bound in this case will be an 80. Our upper will be 90, right? So, because they give us the lowers and the uppers there. What's the mean? Well, the mean is, they have to tell us the mean. The mean is, in this case, the mean is 75. It's not 0 anymore because it's not a standard normal distribution. And the standard deviation is 15. So this is what you put into the calculator to calculate the probability. So let's do that really quickly. Second vars. Okay, normal CDF. All right, so we're going from, what was it? Let me pull it back up. It was from 80 to 90. So our lower bound was 80, upper bound is 90. I believe the mean was 70, was it? 75, and the standard deviation was 15. Paste it, hit enter. There we go, 0.211 if we round out to 3 decimal places. 0.211 is the answer. Okay. So what does that mean? That means that there's a 21% chance that a score is between 80 and 90 based off of that distribution there. Okay, so we got the heights of high school age males are normally distributed, mean of 72, standard deviation is 4.5. Find the probability that a high school male is shorter than 64 inches. Shorter than 64 inches. So what that means is that, first of all, let's convert this over to probability notation. So the probability that, we got to figure out the probability that a high school male's height, so the random variable x, is shorter. Shorter means less than 64 inches. Excuse me, less than 64. Okay. So you may have a question, why do I use an x instead of a z? Well, remember, for the z distribution, we have to have a mean of 0 and a standard deviation of 1. And here we do not have that. We have a normal distribution, but it's not the standard normal. All right, so this means normal CDF. Anytime it says find a probability, it means normal CDF. We need a lower. Okay, so we're talking about a person being less than 64 inches. Less than 64 implies that we can go infinitely to the left, so that's a negative 1e99. Our upper bound will be the 64 inches. What's the mean here? The mean will be 72 inches with a standard deviation of 4.5. All this information is given to us in the problem. So now it's just a matter of throwing this into the calculator. Here we go. Okay. Second vars, normal CDF. Let's see our lower bounds at -1E99. Upper bound is a 64 with a mean of 72, I believe, and the standard deviation was 4.5. We paste the bad boy to the home screen, hit enter. There we go. 0.038 is our answer if we go to 3 decimal places. 0.038. There we go. Let's get another one in here. Okay, all right, so that's it for those. So now another thing that we can do is, so we've talked about, once I know the z-scores, we talked about how to get the probability. Well, now, how do we go backwards? Let's say we know the probability. How do we get the corresponding z-score or the corresponding x value? Okay. In that case, we're going to use something called inverse norm in the calculator. And so that's what they're going to show you here. So inverse norm, that function, is right underneath normal CDF. You can see it right here. So to get to it is the same way as you get to normal CDF. You hit second vars, you select inverse norm, and then inverse norm requires 3 things. Here, I mean, the notes here, they say the slide here, this says probability, but I like to instead think of it as an area, specifically an area to the left. Okay, so the calculator needs the area to the left, it needs the mean of your distribution, and it needs the standard deviation. And what it's going to do is just going to do the reverse of what we did, and it's going to tell you the z-score, or if it's not a standard normal distribution, it's going to give you the x value that leads to that specific probability. Okay, and they're just showing you more information there. So the syntax is, like I said, left area, give it the mean, and then give it the standard deviation. Okay, if your calculator is not updated, you have to put in that order, comma separated. If your calculator is updated, I'll show you as mine is. It'll ask specifically for the area, mean, and standard deviation. But keep in mind, it's got to be the left area. Okay, here we go. So the volume of milk cartons filled by a machine is normally distributed with the mean of 504 milliliters and a standard deviation of 1.5 milliliters. What is the maximum volume of milk that is in the lower 75% of the distribution? Okay. So maybe I should draw a picture before we jump to the calculator. What they're saying is this. We've got a normal distribution. Okay, it's not the standard norm, but it's a normal distribution. So let's talk about x's. And right down the middle, if you recall, we are centered at the mean. So they told us the mean is 504. So right down the middle is where x is 504. And we're trying to find the volume of milk that represents the 75, that represents the maximum value of the lower 75% of the distribution. They're a little wordy here. What they mean is the 75th percentile is really what they're asking for there. And what they mean by that is right here. I'm going to draw a line right here. I'm going to call this x sub 75. What I mean by that is the 75th percentile, meaning whatever this number is, whatever this value is, it represents a value that's higher than 75% of the rest of the data values. All right, think about whenever you take a test and they said that you scored in the 90th percentile. It doesn't mean that you got a 90 on the test. What that means is that you scored higher than 90% of everyone else that took the exam. So what that means for us basically is that if you're trying to find the 75th percentile, is what this question is asking, we need to understand that the area to the left is 75%. That's what it means to be in the 75th percentile. It means the area behind you or the area to the left of you is 75%. Okay? So now with that known, we know that, okay, remember inverse norm requires 3 things. It requires an area. So now our area will be the 0.75. Our mean is going to be 504. They tell us that. And our standard deviation will be the 1.5 milliliters. So we're now going to feed that information into the calculator. So let's clear this screen out. Second vars, inverse norm, number 3, hit enter. As you see, my calculator is updated. Remember, if you're not updated, you have to put in 3 things for inverse norm, comma separated. We said the area to the left was 75%, so 0.75. The mean is not 0 anymore. The mean was, I believe it was 504. And let me double check on the standard deviation. It was 1.5. Okay, we put that in. And then 505.01 is our answer. 505.01. Okay, and so what does that mean? This question was not asking for a probability. This question was asking for a value, an x value in this case, such that 75% of the area is to the left of it. Well, based off our information, we found out that 505.01 is the value, so that 75% of the distribution is to the left of that number or behind it. Here we go. For example, suppose the heights of high school age males are normally distributed with a mean of 72 inches and a standard deviation of 4.5 inches. What is the maximum height of a high school male shorter than 80% of the distribution? So once again, they're asking for the 80th percentile is what they're asking for here. The 80th percentile. What is the guy that represents the height that's higher than 80% of everybody else? Okay. So to do that, that means the area to the left is 0.80. So maybe we should make note of that. So the area is 80. The mean is 72. And the standard deviation is 4.5. Let's feed that info into our calculator here. Second vars, inverse norm, 80%, so 0.80. I believe the mean was 72 with the standard deviation of 4.5. Let's put that into our home screen there, hit enter, and 75.787 is our answer there, 75.787. So I hope the answer is 75.787. Let's see, do I have the answer here? Hey, there we go. So basically, they're just telling you how to do this thing in the calculator, right? We inverse norm, we put in our left area, we put in our mean, and we put in our standard deviation. And yes, 75.787 or 75.8 if you round it to one decimal place. All right, one more. This is for, so suppose the heights of high school age females are normally distributed, mean of 66 inches, standard deviation of 3.5 inches. What is the maximum height of a high school female that represents the shorter 40% of the distribution? So this is the 40th percentile. Area equals 0.40 because that's our area to the left there, okay? Our mean is 66 with a standard deviation of 3.5. 3.5, okay? We're going to feed that information into our calculator, and it will hopefully tell us the correct answer. Let's see, second vars. Inverse norm, so what is the area to the left was 40%, so 0.40. Let's see, what was that mean? Mean was 66. With the standard deviation of 3.5. All right, 65.11 is our answer there. Okay, so the answer was 65.11. Okay. And I don't have the answer there. All right, so this is just basically how do we use the calculator to help us find both probabilities, and then how do we do the inverse process and find the x value whenever we know the probabilities. See you next video.